Let's take this example from the chapter of collision. This is problem number 43 of your textbook. Problem says a projectile is fired with a speed e at an angle theta above a horizontal field. So you can say this way, the horizontal field projectile is fired with speed e at an angle theta. Now, it also says the coefficient of restitution of the collision between the field and the projectile is E. Now, this projectile, though from the chapter of kinematics, it found at a distance, say, R1, range 1. Now, there is a coefficient of restitution, so this will bounce back, this will bounce back. Now, there is a restitution, so it will definitely not go up by the same amount, and it will drop somewhere here. Trajectory, this is second trajectory. Let's say this range is R. And how far from the starting point does the projectile makes its second collision with the field? That means we have to find out R1 plus R2. Now, you know from the chapter of kinematics that R1, the chapter of kinematics, range is equal to square sine of 2 theta, u square sine 2 theta. The standard equation from the chapter of kinematics, and you have to really recollect or remember this, memorize this form. R1 is formed. Now, the point is, there is a point is, you know also that it is U, then it hits the ground from the chapter of kinematics at the same angle theta with the same velocity U. So at this point, what happens? At this point, hits the ground with the same velocity u, and this angle is theta. And this angle is theta. This u has two components. One is vertical component, which is u sine theta. U sine theta. This has got a horizontal component of u theta. Now, the body was traveling horizontally with a speed of u cos theta. Obviously, there is no collision with u cos theta because it's a horizontal speed. So, the rebound speed, the horizontal velocity will be same as u cos theta. But the vertical velocity component, which is u sine theta, will rebounds with the coefficient of restitution E. So this velocity will be EU sine theta. EU sine theta. So rebound's velocity here, the horizontal velocity is U cos theta, and the vertical velocity is E sine theta. EU sine theta. Obviously, this angle is different from theta. This angle is, let's say, this angle is phi. Of course, we don't have to measure this angle. Just for your understanding, I'm writing that this angle is different. Now, that means it goes vertically up with a velocity of u sine theta. Now, if in the second round, the time to reach a highest point is equal to t. Then from the law of kinematics, once again, we can find out t. So highest velocity is 0 is equal to initial velocity was EU sine theta minus gt. From here, we find t is equal to n theta by. So it reaches the highest point here with the time t. So naturally, it comes back also with the time t. So total flight time. So total flight time is equal to 2 by g. Now, during this total time 2t, it travels horizontally with a velocity u cos theta. So we write during this time, travels horizontally velocity u cos. So the range R2 is equal to capital T, that this total time range R2 is equal to 2 theta by g sin theta by g multiplied by u theta. This is equal to e square u square by g 2 n theta cos theta. Sine of 2 theta. Then, so total range is equal to R1 plus R2. R1 was u square sine 2 theta by g, u square sine 2 theta by g plus square sine 2 theta you have here is u square and 2 theta by g, that multiplied by 1 plus e. So this is the desired answer to the question. Okay. Now we shall go to the next question.